It is estimated that only about 30% of California residents have adequate earthquake supplies. So suppose we are interested in the number of California residents that we must survey until we find a resident who does not have adequate earthquake supplies. Okay. So what we're going to be looking for is how many fails do we have until we get to a success. Okay. Now let's define what success and failure means. So we are looking for the resident who does not have adequate earthquake supplies. Okay, so this is success will be defined as does not, and fails will be defined as does. Okay. So we can define our random variable now. Let X be the number of California residents surveyed until a resident is found who does not have adequate earthquake supplies. So what is the probability of failure in this case? Well, we're given that. This is the probability of having adequate supplies, as we've defined that, and having adequate supplies, that's about 30% of the residents. So the probability of success in this case will be 1 minus the probability of failure, which is 1 minus 0.3 or 0.7. Okay, so let's list all the values that the random variable could take on. Okay, so if X is equal to 1, that would mean that we surveyed one person and that person did not have adequate supplies. Or it could be 2. Or it could be 3, and it can keep going all the way up until we get to, in theory, the entire population of California. So let's state the distribution. This, we are looking for failure, 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 and then success. So this is a geometric distribution. And the geometric distribution, the parameter is the probability of success. And remember how we've defined success? This is the probability of not adequate supplies. So this random variable X follows the geometric distribution 0.7. All right, so what is the probability that we must survey only 1 or 2 residents until we find a California resident who does not have the adequate supplies? So we could look that this is the probability that X is equal to 1, or that it took 2 people. Now, if we were doing this by hand, then we would say, okay, that would be the probability that X equals 1 is 0.7. If it took 2 people, we would have had a failure first, and then the success. And this is equal to 0.9. Now, the other thing we can realize here is that when we're talking about summing up X equals 1 and 2, we're really talking about the probability that X is less than or equal to 2. And we could use our calculators for this. We would look at the geometric. Now it's accumulation, so we need the CDF. It follows 0.7 and then 2. And again, we would get 0.91. So what is the probability that we must survey at least 3 California residents until we find a resident who does not have adequate earthquake supplies? So in this case, we're looking for the probability that X is greater than or equal to 3. We cannot solve this, right? Because the random variable could go all the way up to the entire population of California. All right, so we should use the complement here. So the probability that X is greater than or equal to 3, its complement is 1 minus the probability that X is less than 3. All right. But remember, this is a a discrete distribution, so being less than 3 would not include it. So really what we're looking for is 1 minus the probability that x is less than or equal to 2. And we just found that up here. We saw that that was 0.91. So the probability that x is greater than 3 is equal to 1 minus 0.91 or 0.09. So how many California residents do we expect to need to survey until we find a resident who does not have adequate supplies? Okay, so we're looking for the expected value of success, that is the mean, right? We saw the mean is equal to 1 over p. So in this case, p, the probability of success, was 0.7. And when you put this into your calculator, we get 1.4286. And since we're talking about how many residents or people, I would say we would need to then survey 2. Now let's determine the variance of the distribution. So we're given that sigma squared is equal to 1 over p times 1 over p minus 1. So that would be 1, just filling it in, 1 over 0.7. 1 over 0.7 minus 1. And when you put this into your calculator, you should get 0.6123. And then if we're looking for the standard of deviation, we know the standard deviation. We know the standard deviation is the square root of sigma squared, which in this case is the square root of 0.6123. And that is approximately 0.7825.